Welcome, guys. So basically, we have done some questions earlier today in the morning, which is like remove duplicates from sorted array. I tried, I did it. I did so much try hard for a very simple question, but anyways, we learned something from it. Now it's time for left rotate array by one place. Now, how would I understand? And how would I actually get to know that I have to solve this is through this notion. So I created this notion. So this is not started yet. I will make it started. These two things are also required. Like I am also learning AC2, AWS. So yeah. So basically I need to put it on done, not done. Sorry, in progress. And let's start without any further ado. So basically this is a rotate, not this. Okay, remove duplicates is done. Left rotate an array by one. Left rotate an array by one. Okay, this we will do later. This is a similar question. Let's paste this here. Left rotate an array by d by 1. Let's do it by 1. Okay, so we have got an array of 1 2 3 4 5. Now we want to do this one, right? So basically we are getting 1 2 3 4 5, and every element moves to every element will move from its place to array of total length modulo its place. Length modulo place. That means, what is 5 modulo 0? What is 5 modulo 0? Please keep it 0. Hey yo. Okay. Arithmetic exception. Cool. Arithmetic exception is what I'm getting right now. So this is not this one, this is modulo. Okay, so this is the first element, second element, third element, fourth element, fifth element. Okay, so it becomes plus 1. Okay, if you do it like this, then this will become array of 0. Let's start with array of 0. So array of 0 will become 5 modulo 1 0. Okay, cool. 1 modulo 5, 1 modulo 5, right? So 0 plus 1 modulo 5. So if I try with 0 plus 1 is 1 modulo 5 is of course 5, sorry 1. And then when we do 5 modulo 5, it becomes 0 if I'm not wrong. Yes. So this, I remembered this, I solved somewhere. So that means for every iteration it will be like this, correct? 3. So these are all the iteration. So the value of a will become 1 plus 1 modulo 5. So that means 2 modulo 5, the value will be 2. So this is what we are gonna do actually. So let's remove all this. Let's put these two. Okay, for int I is equal to 0, I is less than arr dot length I plus plus for every number a of o will be equal to a of 5 arr dot length in this case it is 0, right? So I plus 1 modulo arr dot length. Let's try to compile this. A of 0, a of I. I cannot find symbol. Say, how can I do this many mistakes, dude? Okay, because I'm rushing. Oh. One. Okay, left shift 1. That means value. This is completely wrong. So that means 1 आगे. That means if 0 let's go to Excali. Better. So I have an array called 1 2 3 4 5. I want to left shift, so the value of this one, and this value I have to do something like whatever so we have to use modulo. So first time when I will compare, I will make this, see, this is 0 1 2 3 4. So let's go from ulta. Okay, first time I will compare, I'll make arr of I as arr of plus arr of 4, which is 5, becomes arr of 5. One. So if 1 is there, then it will 5. 5. 5 5 modulo 4. So this will actually become like this. Correct. Clockwise. Yeah, this is clockwise. Sorry. This will be the direction that we need to change. Okay, let's do with 1 modulo 5. Cool. So we have to make it like this. So basically this is the array, and we have to make it 5 1 2 3 4. So what we can do here is we can shift 1, shift again 1, and shift again 1. But when this comes, we have to do something for this. So can we do first element 5 modulo second element, 5 modulo third element, 5 modulo fourth element, 5 modulo fifth element becomes 1. So we will do a for loop. Okay. So that means we have 1 2 3 4 and 5 modulo 1. So this is 1 2 3 4 5. We have num start length is equal to 5, element is equal to 1. Okay, first element. Now for int I is equal to 1, I is less than nums dot length equal to nums dot length plus. Let's keep it this way, 0. So the first element will become, that is ARR of I will become ARR of, in this case, nums first element. The first element. So anyhow we have to do first element will become fifth. First element will become fifth. 5. How? What is the nums dot length? You have nums dot length, which is 5. Let's go with the last index. Nums length minus 1. हेलो गणेश पूजा के लिए चंदा मांगने आए थे. These are the people of our society only, good people. So yeah, where were we? हाँ, तो अभी so this is what we need to do, right? We need to shift it to 1 back. The value. So how can I shift it to 1 back, 1 value? ARR of I will be ARR of I minus I knew these guys facing a lot of difficulties these days. So this is 5. Now what I need to do is I need to shift the value 1 left side. If I shift the value 1 left side, this will become 1 will become 5, 2 will become 1, 2, 3, 4, and this is what we want actually. So in which case yeah, so 5. So in which case this value will top 1 0. Let's make it. Okay, let's keep it this way. And let's also keep it first element, second element. So 0th index. This is the value, and we are gonna do minus this one, right? So how it is going to become? One, 2, 3, 4, 0, right? 1, 2, 3, 4, 0. Four plus one more. 7 module 6 modulo. हो गया 4 plus 0. Zero is equal to what's the problem? we got the array, we got the last index. What is the last index? 4. So where is the last index? ARR dot length is 5 minus 1, that is 4, last index. So first I is equal to 0, first iteration, I is greater than ARR dot length, yes, correct, I plus plus, okay. ARR of I, which is 0, ARR of 0 will be becoming ARR of last index plus 1, last index plus I. Will become ARR of 4. Now what is the second one iteration? I becomes 1. That is, this one will become to take a temporary array. Understood. Now ARR of length 4 plus 1, I'm really sorry, 5 in this case it will become 5. Yep. but this is expected or not, I don't know. %, accuracy. Okay. I knew it was modulo, but the way I have written it for modulo 1. The length. Okay, this is done. Let's watch. That's done by me, by the way, guys. So I will keep that in done stage. Where is it? We'll watch the video and see how he optimizes it. Rotated array.
And in this video, we will be covering these 5 problems. Just in case you wanna directly jump to any particular problem, the timestamps will be there. You can directly jump to it. But let's just start with the first problem, which is.
So I'm watching this actually. This is the optimized.
And then we go on. Given that the good and better exists for that problem, and this is the way you should always tell in an interview. Why? Because in an interview, your thought process should be visible to the interviewer, because it's you who will be driving the interview. So make sure you follow this particular step-by-step optimization of approaches, because it does leave a very positive impact on the interview. Now coming back to the problem, left rotate the array by 1 place. What does it mean? So given an array, you have to left rotate it. Yes, you have to left rotate it by 1 place. So if I have this array and you have to left rotate it by 1 place, so 1 place. So one element will go and rotate it. So basically, this one will go to the end because you rotate it, and everyone will move a bit because you're rotating it. So it will be like 2, 3, 4, 5. So this is what rotation means if I'm talking about left rotation. So I have rotated the array, and this will be my final array. Now for this problem, this is a very easy problem. So you can directly jump to the optimal solution instead of going like to the group where you take another array and store the answer in another array. It's not required. For
Not
this problem,
required. Okay.
you have to solve the problem in the given array itself.
Okay.
Like you cannot use
That's
any
what-
new array.
That's
Make
what
sure
I
you solve
wanted,
problem
to
in
use the
given
array
itself.
in the given
Now
array.
since it has been clearly stated
Such
that
a
you just rotate it by
idiot
one
I
place.
am.
Hence the problem is very simple. After that, we will be increasing the difficulty of the problem. But as of now, let's understand how how do you left rotate by one place? Now I know one thing. If I have to talk about left rotation, let's visualize what happened in the final array. In the final array, this is the only guy that went to the last. The first guy is the only guy that went to the last. And apart from that, what happened? The 2 moved here, the 3 moved here, the 4 moved here, the 5 moved here. That's like they moved one place ahead. So moving them one place ahead should not be a big deal. But we need to store this one. So assume I say temporary equal to array of 0. And over here temporary will be stored as 1 because array of 0 is 1. Now what I say is, okay, I'm standing here. This 2, ideally, since it is left rotated by 1, should go at the 0th index. So I'll place it here. So it's like saying, okay, if I'm at ith index, I'll place it at 1 index before. And then again I'll move the ith index and I'll say, place it at 1 index before, which is again the I minus 1. And then again I'll move the ith index and I'll say, place it at 1 index before. So this will be placed here. Then I'll move here and I'll say, place this 5 at 1 index before. So this will be placed. Once I've done this, the iteration will be over. Once the iteration is over, the last place is having 5 as of now. We need to take this one and place it at the last place, and the 1 is stored in temporary variable. So you take this temporary and put it into the last index. So this will take 1. Hence the array will get modified to this after left rotating it by 1 place. Now let's talk about the implementation. How will you implement it? Can I say this is nothing but the first index and this is nothing but the n minus 1th index? So thereby what you can do is you can say for I, like at first what you can do is you can always store temporary of array of 0, and then you can start from 1 and you can go until n minus 1. So you can run a loop till n minus 1, and then you can say this ith guy will go to I minus 1. So array of I minus 1 will store array of I. Once this loop is completed, that means this will be completed, and at the end of the day, at this position, which is nothing but array of n minus 1, whatever we stored in temporary, we take it and we will place it over here. As simple as that. If I have to discuss the time complexity, what will be the time complexity? Yes, a simple bgo of n pass, because we are running this loop for n times. Thereby the time complexity is bgo of n. Are we using any extra space? No. Thereby the space complexity is bgo of 1. Why? Because we are doing everything in the given array itself. So we can see that we are not using any extra space. But yes, we are modifying the array. So the space used to solve
modifying the array
is bgo of n, because we're using an array to solve the problem.
My approach is a
that array is
little bit
already
bad.
there, but we are using it. So if
Not
someone
little bit.
says what is the space used in your algorithm, then it becomes bgo of n, because you definitely are using this array, but it is already created, but you're using it in your algorithm. But if someone says what is the space that you're, like what is the extra space that you're using, then the extra space is bgo of 1. But for the algorithm, we definitely are using this. So understand the subtle difference. If someone says in the algorithm, you should always take the space that you are being used, like that's being used. And if someone says what's the extra space, then you can say bgo of 1. So there's a subtle difference. Whenever you go to an interview, always clarify it. Tell them that, sir, the extra spaces. So whenever you go to an interview, always clarify this. Tell them, sir or ma'am, the extra space that I'm using is bgo of 1. But in order to solve this problem, I'm using this array. So if you have to take space into consideration for the algorithm particularly, I will say I'm using this array. So thereby a bgo of n space is being used. Yes, it's already given to me, but I'm using it in order to solve it. So this way you tell to the interview, so that every concept of yours is crystal clearly presented to the interview. So thereby a bgo of n space is being used. Yes, it's already given to me, but I'm using it in order to solve it. So this way you tell to the interview, so that then you can say bgo of 1. So there's a subtle difference. Whenever you go to an interview, always clarify it. Tell them that, sir, the extra spaces. So whenever you go to an interview, always clarify this. Tell them, sir or ma'am, the extra space that I'm using is bgo of 1. using this array. So if you have to take space into consideration for the algorithm particularly, I will say I'm using this array, so thereby a big O of n space is being used. Yes, it's already given to me, but I'm using it in order to solve it. So this way you tell to the interviewer so that every concept of yours is crystal clearly presented to the interviewer and he is impressed. This is how you should write the interviews. Got it? So if you want to solve this problem, the problem link will be in the description. So I've written the exact same code and I'm submitting this problem and it is running absolutely fine. So I've solved this problem. Now if this problem comes up in an interview, the follow-up question very likely will be the next one, which is left rotating an array by d places. Till now you've solved a problem where you did left rotate the array by one place. Now I am telling you, okay, 1 is easy. What if I give you 2? What if I give you 3? What if I give you 4? Can you left rotate an array by certain number of places? So that certain number is d. D can be anything in a problem. So you have to design an algorithm so that the algorithm works for any given number of places. That is what the follow-up question will be. So let's try to solve this follow-up problem. So let's understand the problem statement. It states you to left rotate the array, but this time by d places. Assume for this given example array, we have d equal to 2. So it's stating that left rotated by 2 places. So these 2 elements should be left rotated and these elements should be moved by 2 places. This is what you mean by left rotation. So if I do that, the resultant array will be 3, 4, 5, 6, 7 and then 1 and 2. So this 1 and 2 kind of moves here and then moves here and these will move 2 places ahead. So this is what the resultant array will be after you have left rotated the array by d places. D over here is 2. D could have been 3. Yes, D could have been 3 as well. In case of 3, what would have been the answer? Yes, obviously. In that case, 1, 2, 3 would have been left rotated and they would have been moving by 3 places ahead. So in that case, the answer would have been 4, 5,
correct.
6, 7 and then 1, 2, 3. So that's the answer for D equal to 3. Now,
this is d
what if,
spaces.
yes, what if, like, let's count
Similar
the
question, that's one.
It's like 1, sorry, my bad. 1, 2, 3, 4, 5, 6, 7. 7 is the size of the array. Imagine I ask you, can you rotate this? Yes, can you rotate this by 7 places? So if you actually rotate this by 7 places, it will again come back to the same place. It will again come back to the same place. So rotating it by 7 places will bring it back to the same place. So if I ask you, can I rotate it by 8 places? If you do a rotation by 8 places, can I break 8 down to 7 rotations plus 1 rotation? Can I? I can. So can I see that? Hey, listen, on 7 rotation, it comes back to the original array. And then you just have to do 1 rotation on it. Makes sense? So if it is 9 rotation, can I break it down to 7 plus 2 and say, okay, on 7 rotation, it will be the original array again. And then you just have to do a meager 2 rotation of the array. Does make sense? If I tell you d equal to 15, can I write 15 as 7 plus 1, stating that on 2 7 rotations, the array will be back to its original. And then you just have to do 1 rotation. And that will sum up to 15 rotations. So can I see multiple of 7 rotations can be done? And it will always bring you back to the original array. I repeat, multiple of 7 rotations will always bring you to the original array. The remaining is what you need to do. So can I say whatever array is given to you, whatever D is given to you doesn't matter. The number of rotations you have to do will
If it becomes 7, it repeats modulo.
Whatever is the size of the array. Can I say this? If it's given like 20, doesn't matter. I'll just have to do 6 rotations because 20 modulo 7 will be 6, which means you have to do 7 2 times and the remaining 6. So you actually have to just do 6 rotations. And if you have any number of rotations which is lesser than the size of the array, it's very simple. If I say 6, it means this will go here. It's like 1, 2, 3, 4, 5, 6 and this will go here. That is the meaning of 6 rotations. So anything lesser than 7 is very easy to solve. That's why we will always do a modular of n, because n rotations, like on multiple of n rotation, means coming back to the original array, which we do not care. We care about doing the next set of steps. Got it? So that's the first thing we have to be careful about. Whatever d is given to you, just do a modular with n, and that will be solving your problem. And that will be solving your problem if d is very, very low. So if in an interview this question comes up, the first approach that you'll be telling will be the brute force approach. Now, what will be the brute force approach over here? Let's go back to the previous problem. In the previous problem, d was one element. Yep, you were being asked to rotate the array by one place. So you initially took a temporary and you stored one element. This one element was stored, and then you did this, and then you replace that one element to the last. We'll do the exact same thing. D was 1 over here, so you stored one element. If D is 2, you will be storing two elements into this temporary, and then you will rotate, and then you will take the two element and you will put it on the back. That's what we will do. Let me explain. So what I'll say is, okay, D is 3, so I'll take a temporary array or a temporary list, whatever you can, and I'll say, okay, let's take the first 3 elements. Very simple. Done. So I've taken the first 3. I've taken the first 3 and I've put that into the temporary array, similar to what we did in the first problem. Now, what was the next step? Shifting. So let's do the next job of shifting. Now, when I say shifting, how will you shift? Let's write down the indexes and let's try to observe how do we shift. So if I write down the indexes, it's like 0, 1, 2, 3, 4, 5, 6. And if D is 3, we start shifting from third index. We start shifting from the third index, which is the dth index. So we start from, and where do we put 3? Let's analyze. 3 is put to the 0th index. Obviously 4 will come here. And the 4th index is put to the 1st index. This one will come here. And then the 5th index, which is this, which is 6, is put here. So 5th index comes to 2nd. Do you see where it is coming up? If this is your ith index, it's always coming
I minus t.
I minus d place. This is where it is coming. The shifting is happening in this way. So what I can say is, okay, for shifting, I can
Start from D.
Start from this one. Sorry, this one, which is the third index, which is nothing but D. And I can go until the last, I plus plus. And I can say array of, because the third index guy will go to the 0th index guy. Please observe, this guy goes here and this will become 4. So it goes
Array of D.
3 places back. It goes
Array,
D places back.
Array of
so
D minus
I minus D places
okay.
is where the array of
I should be.
So once you have performed this shifting, how will the array look like? Let's write. Once you perform this shifting, how will the array look like? It will look like 4 is here, 5 is here, 6 is here, 7 is here. Then you still have 3 places where 5, 6, 7 is there. What do you need to put? Like, what do you need to put there? Very simple. You have to
Put
take
the
this
temporary variable
and you have to put
and
the
concat
temporary
it.
one by one here, which is like 1, 2, 3. Quite simple. So put back temporary is the last step. Put back temp is your last step. So let's put back the temp. So I can see, how do I put back the temp? Now we need to analyze. Where are we putting it? Let's try to analyze. So can I say, if we are shifting by 3 places, it means if the size of the array is 7, 3 places before it, because the last 3 places will only be occupied if we are shifting the array by 3 places. Only the last 3 places will be occupied. So I'll be like, okay, 7 minus 3, which is basically n minus d, which is basically 7 minus 3, which is basically 4. So we're starting at 4. Can I say we will start putting at the 4th index? Can I? I can. So I'll start putting it from the 4th index, like n minus k, and I'll go on to the last. Quite simple. And what will you
Yes.
put? In the
N
array
minus
of 5,
t.
what will we put? We'll put first one. So we'll put something from the temporary. We will put something from the temporary for sure. Now, we need to figure out what's the index. The easiest way to do this is, like without any mathematical calculations or anything, the easiest way is, say j equal to 0 and put j and then do a j plus plus. So what will happen? At first j is here because that's the 0th index. Takes up 1, puts it here. Then j goes here, takes up 1, puts it here. Then j goes here, takes up 3 and puts it here. So you put j and you increment j. You put j, you increment j. And this will easily
append the last 3 places.
That's one of the ways to do it. But if you're going to an interview, you have to show all your skills. So this is the first thing you'll tell in it.
This is the first thing.
Then you can say, maybe we can get rid of this possible j. Yes, let's get rid of this possible j. Can I deduce something which is mathematically correct? I can. Something which I know is, this element which is at the 0th index will always go to the n minus dth index. Can I say this? I can. Now can I say someone who's at the first index will always go to n minus d plus 1, which is basically the next index? I can. Now can I say someone who's here will always go to here, which is apparently 2 places ahead, which is n minus d plus 2. Can I say this? And this is the second index. So n minus d plus 2. So can I say, if your base index is n minus d is your base index, can I say this in temporary will say, okay, if you're standing at I, then you just need, n minus d to get your base index. Can I say this? You just need I minus n minus d, because again I'll repeat, this is n minus d plus 2 and this is n minus d. So if you are trying to put something here, then if you just subtract this, you'll get 2 and you can get the second guy from here. Quite simple maths. Very, very simple. Take a pen and paper and try to do it yourself. I'll repeat again. The base index here is n minus d. Then the next index will definitely n minus d plus 1. The next will be n minus d plus 2. Right? And we're taking from 0, 1, 2. So this is like 0, this is like 1, and this is like 2. That's why wherever you are currently at, just subtract the base index. If you subtract, first you'll get 0, then you'll get 1, then you'll get 2, which apparently means this. So you'll automatically take the temporary. This is how you can easily put it back. Got it? So quite simple. First I stored everything from the temporary. Again, to store everything from the temporary, you just need to move from 0 to d. So it's like moving from I equal to 0, I less than d, and I plus plus. And in the list, you can probably take a vector or a list in Java. Push back in Java it will be list dot add array of I. That's it. So this is the putting into the temporary. This is the step 1. So this is how you can put everything over there. Then you can easily shift, and then you can easily put back the temporary array. This is how you can easily do it. So for this root approach, I have written the pseudocode so that you can code in C++ or Java. But coming to a cleaner code, we just take the array as the input, and then we take the d, and then we call the left rotate function which rotates it, and then we just kind of like print it. So let's look at the function. So it takes an array, it takes the size of the array, takes d, and the first step we make sure is we just reduce the d to something lesser than n, because we know on all the
Hey, if the strike comes, then I'm gone. I think I should not show you guys. Yeah, correct. There is 20 minutes of content that I have shown from drivers. Oh my god. Okay guys, it's time to learn by my own. Oh my god. Sorry Striver.
Multiples of n, it will come.
I need to see this.
Original array, and then we store everything into temporary.
Left rotate by 1 place done. Let's do left rotate by nth place. K elements. K steps. It's not.
Then we shift it, and after that replace back temporary into array. Why it's simple? So that was the cleaner code, and the problem link will be in the description. So what will be the time complexity? So can I say the time complexity will be, in order to do the step 1, this is taking a big O of D, because we are looping through the first D elements. Next, can I say in order to transfer, like shift everything, that's going to take big O of n minus d, because those many elements are what you will be transferring or shifting to the front, so n minus d. The next one, putting back temporary. So that's like again big O of d, because you're putting back d elements. So that's like big O of d, and if I have to add it up, it will become big O of n plus d. This will be the time complexity. And if I ask you what is that, very important one, what is the extra space used? Extra. The extra space used will be big O of d. Why? Because you're using a temporary array to store the extra elements. Now this is where the interview will tell you, okay, fine enough, but I want to get rid of this extra space. Can you just do it and big O of one extra space? That's when you say, okay, maybe I'll try to optimize this into an optimal solution. For this, a better might not exist, so I'll not discuss it. But this is where I'll try to optimize this into an optimal. So let's look at the optimal solution. So let's talk about the most optimal solution. The most
Oh my god, it was a great blunder from my side. I've been keeping it and streaming since forever. So this one, guys, this is the one that I've come up with. I'll show you. Wait. So my submissions, right? So here will be my submissions. Now this will be my submission. Now it is got accepted. 1 minute ago, yeah. So basically, first I'm taking the modulo so that I don't rotate it multiple times. So again, if the k is 0, then I don't need to rotate it, right? So here this thing is important, guys. So for left shift we do first both and then the last one, the whole thing. For right shift we first do the whole thing reverse and then both. So in this way we do left as well as right. We can achieve one of like any one that we want. So we want to do one, then we do one like modulo this one, then of course it won't be 0, so we do this. Okay guys, so we copy this solution and then we write it on the cursor. Left rotate by K. New file. Let's put a new file. Let's start from solutions, guys. Solution.java. Yep. So this is the solution. Left rotate an array by 1. Let's do new file, not new file, new folder. Left by 1. New file, solution. Basically, today actually the learning was too much, but my streaming, I just effed up my streaming basically. Anyway, I'm learning, guys, so I'll keep it more simple. I will think about keeping the stream think about streaming as well. So I hope you understood at that point of time what I said. For left we do first both, then whole thing. For right we do first whole thing and then both, reverse. That's it. So yeah, so this is left rotate by 1, right? So left rotate by 1 I have written in geeks for geeks. So left rotate an array by 1 place. By 1 place. Left rotate an array by D. Left rotate by 1. Yeah. So this was the answer that I gave for left rotate by 1. Oh my god, this is copy. This is solution. If I do git status, add git commit, rotate an array by 1 and even D. Yeah, you do a git commit with a message, of course. Git push. Yeah. So basically, guys, we have done it. We have learned how to left rotate and how to right rotate. This was amazing. Thank you for keeping up with my bad streaming abilities. Thank you guys.